All right, so objective 4, we are going to now solve applied problems using quadratic functions as models. In other words, they're going to give you the equation for your quadratic function, and you're going to be asked to find a series of things to do with it. So the first thing I want to go over is what this one looks like. So this is height as a function of time. And they'll always tell you with an initial velocity of blah, blah, blah. But that's just what they use to be able to come up with the equation. What's important for you is that your y value is height and your t is your x value. Now, I happen to know that this one looks like this. It's a ball thrown from the ground. Some of these might look more like this guy, in which case you'll have this part that's behind. It's still height as a function of time. And so you're going to be asked a series of 3 questions potentially. The first one being, find the time it takes for the ball to reach a height of 48 meters. So if this is the scenario, you put 48 somewhere up here and you're looking for the time when the ball hits this height. In question B, it says how long will the ball be in the air? So sorry for this one too. The 48 would be here. So whether the ball, and the only difference between these two is this one, the ball is thrown from the ground. So the height is 0 at time 0. And this one, the height is the ball is thrown from a certain height. So maybe they're throwing it from their hand above their shoulder or something like that. So the first question again was find the time it takes for the ball to reach 48 meters. So that would just be a line across. There'll be 2 times because it's a symmetrical parabola. The second question is how long will the ball be in the air? In this one, you'll get a time of 0 and the time of something. This one, you'll get a negative time and a positive time. But for both of these, the time to be in the air will just be this positive time. So again, this is just because the parabolic shape would continue, but because this is a ball thrown, you'd only start at time 0. So it's always just the length of the time to that positive answer. And then the third question that you can be asked is what is the maximum height? What is the maximum height the ball will reach? And so then that is asking you to find the vertex. And on both of these, it would be the same. So now what we're going to do is we're going to go through and solve these 3 questions for this problem. So just give me a second just to erase this because I need all the space I can get. And the first one we're going to do is what time it will take for the ball to reach a height of 48 meters. And so you're going to use this equation, h of t is equal to 80t minus 16t squared. And we're going to plug in for the height. There we go. Okay, so the equation is h of t is equal to 80t minus 16t squared. And in the first one, you're going to find when does it reach a height of 48 meters. So in for the height as a function of time, we're going to just put in 48. And then what I want you to notice is that you end up with a quadratic equation. You can solve this by factoring. You can solve this by completing the square root method, and the quadratic formula. Now, this one you're definitely not going to do square root method. So regardless of the other 3 methods you choose, you have to make it equal to 0. So I'm going to move everything over to the right-hand side. So I'm going to add 16t squared to each side. Keep writing 16t squared. I'm going to subtract 80t. And I end up with this function. I've got 16t squared minus 80t plus 48 is equal to 0. Now I'm trying to solve for t. So in other words, what value of t will make this equation true? Again, I could factor. Now, regardless, I am actually going to factor. I'm going to notice that I can take out a greatest common factor of 16. So I've got t squared minus 5t plus 3 is equal to 0. Now, like I've been mentioning, you can leave that 16 out there if you want, but because this is an equation, I could actually divide out the 16. So I could be left with t squared minus 5t plus 3 is equal to 0. Now what I want to do is one of the following, either factor, complete the square, or quadratic formula. I always try to factor first, so I'm looking for 2 numbers that multiply to give me 3 and add to give me negative 5, which is never going to happen. I could complete the square with this. If you do complete the square, just be aware that you're going to be dealing with decimals, which isn't such a big deal, or fractions if you wanted to. And then option number 3 is that we could use the quadratic formula. So let's go with that option. So with that option, we've got A is 1, B is negative 5, and C is 3. So we're solving for t, which is my x value, and it's going to equal negative b plus or minus square root of b squared minus 4ac all over 2a. and I'm going to plug in. So I've got negative 5 plus or minus the square root of negative 5 squared minus 4 times a is 1 times 3 is c, all divided by 2 times 1. And then I'm going to simplify, so negative 5 is just 5. And then 25 minus 12 is 13, all over 2. Now it says answer to 1 decimal place if necessary, so my two answers will be 5 plus the square root of 13 divided by 2, and t will equal 5 minus the square root of 13 divided by 2. And then all I'm going to do is plug that into my calculator, so 5 plus the square root of 13 equals, divided by 2 is 4.3, and 5 minus the square root of 13 all divided by 2 is 0.7. So what does that mean? Well, it means at 0.7 seconds and at 4.3 seconds, the ball will be at a height of 48 meters. So it says find the time it takes for the ball to reach a height of 48 meters. It's a bit of an oddly worded question, so therefore it will be at 48 meters. Now the way that's worded makes me think that we would just say at 0.7 seconds, but we'll just be careful and say it will be at 48 meters at 0.7 seconds and again at 4.3 seconds. All right, moving on to the next question. The next question says how long will the ball be in the air? So again, we've got height as a function of time equal to 80t minus 16t squared. This time they want to know how long the ball will be in the air. So thinking about that drawing again, height as a function of time, we're looking for the entire time that's going to be in the air. In other words, we want to know from where the height is 0. So we're going to plug in 0 for height, and then we're going to have 0 equals 80t minus 16t squared. Now this one, I like always writing it in descending orders of power, so I'm going to put negative 16t squared plus 80t, the commutative property of addition. And then again, you can solve by factoring, square root method, completing the square, or quadratic formula, and all of these will work. But I hope you notice that this one I could factor. This one, because there isn't that constant on the end, I can just greatest common factor out negative 16t to be left with t minus 5. So now that I've set it equal to 0 and I've factored, now I can set each factor equal to 0. So what would make negative 16t equal to 0? Well, if I divide by negative 16, I get t is 0. What would make t minus 5 equal to 0? When t is equal to 5. So that means the ball was on the ground at 0 seconds and again at 5 seconds, which means that therefore the ball was in the air for 5 seconds. All right, last question. The last question says, what is the maximum height that the ball will reach? So again, maximum means that we're going to find the vertex. So our equation is h of t is equal to negative 16t squared plus 80t. I'm just going to go straight to writing it in descending order. To find the vertex, we have two methods. We could complete the square, which would give us the x value and the y value of the vertex, or we can use the vertex formula. Now, if I was going to go to complete the square, you factor the coefficient, the leading coefficient off the t terms. So you get negative 16 times t squared minus 5t. Now, you can complete the square with this if you want to. You would take half the middle term squared. Now, 5 divided by 2 is 2.5. You could do that as 5 halves and square it, or you can keep it as 2.5. If I square 2.5, I get 6.25. That's not too bad. So I'm going to add 6.25, I'm going to take away 6.25. I don't want the negative, so I'm going to take it out of the bracket. I'm going to end up with negative 16 times t minus 2.5 all squared. And then that negative 6.25 times the negative 16 gives me 100. Which means that my vertex is 2.5 and 100. What that means is that when x is 2.5, y is 100. Y being height, x being time. So therefore, at 2.5 seconds, the ball will be at the max height of 100, what are we in, feet? Meters, perfect. Meters. If this is daunting to you and you don't want to complete the square because the middle term wasn't even, feel free to use the vertex formula. So vertex formula, you can do it of the factored form, but I would do it just straight from here. So I would say that t, so again, let's just write down that equation. H of t is equal to negative 16t squared plus 80t. To find the t, or the x value, you go negative b over 2a. So the negative b would be negative 80 over 2 times negative 16. If I plug that in my calculator, I get negative 80 divided by 2 divided by negative 16. Or you could do negative 80 divided by 2 bracket 2 times negative 16. But regardless, you get 2.5. And then to find the height at 2.5 seconds, you just plug in t is 2.5. And if I plug that in, I get negative 16 times 2.5 squared plus 80 times 2.5. And hopefully we get 100, and we do. So it's totally up to you which way you do it. Completing the square, even though that middle term wasn't even, it wasn't that bad to do because it was nice decimal places. Or you can use the vertex formula. But regardless, those are the 3 questions you can be asked to do now. You can find a time for a certain height, you could find the total time in the air, and you can find the maximum height that a ball will reach. All right, good luck.